This is AS1 January 09 question 1. The list below gives a number of physical quantities and units. For those which are base quantities or base units, place a tick in the appropriate box. So we're looking for base quantities or units. And so coulomb, first of all, well, coulomb is charge and charge is current by time, so it's not one. Force, again, is mass by acceleration, so it's not one. Length is obviously a base quantity. Mole is a unit, and it's a unit for the amount of substance, so it is also ticked. Newton is a derived unit, it's a derived unit for force, and we've worked that out by using the units for mass and acceleration. And then temperature is the third one there. What are the base units of kinetic energy? So I'll just do this. It's a good idea maybe to try and remember this one, but K equals half mv squared. We ignore the half, and so the units are kg ms to the minus 1 squared, and you have to square everything in here, and that comes out to be kg m squared s to the minus 2. Explain the difference between a scalar and a vector. So this is about the third or fourth time we've met this in about 4 years. So scalar obviously again has only got size or magnitude. I'm just going to write mag. And a vector has both magnitude and direction. A student states that kinetic energy is a vector quantity because it involves velocity, and that velocity is certainly a vector. However, another student says that kinetic energy is a scalar. The second student is correct. Explain why. Well, the answer is that kinetic energy, or any type of energy, has no direction. But they also suggest the thing that I would have asked you to do, in that if you square the v, it's half mv squared. If you square the units, if you square the fact that it's a vector, then when you square that, remember I would have said that if you let all your scalars be pluses and your vectors be minuses, when you square minus you get a plus, so plus times a plus gives you a plus, i.e. that's a scalar. So because velocity is squared, and that negates the idea that it's a vector. I think I would stick with that first answer. It's easier to explain, just that energy has got no direction. And then the next part of the question is a vector question. Figure 1.1 shows two vectors P and Q. And this question came up a few years previous to that, and I would have given it to you as a homework. In the spaces below, sketch the constructions necessary to obtain the vectors A and B, where A equals P plus Q and B equals P minus Q. So the P's across to the east and Q's to the south. So when I draw A as P plus Q, then I'm drawing P across and Q end to end. And then it's looking for you to label A, that one's P and that one's Q, and therefore you have to draw in the resultant vector and put an arrow on it and call it A. Then the next one is B is equal to P minus Q. So if you look at where Q is a vector which is going down the page, minus Q is going to be up the page. And therefore if you draw a vector diagram which you want to be a resultant, where you want to put in a resultant, this time you would need to put P at the bottom and Q going up the way. That's actually minus Q. It's going up the way. And this time then B is going in this direction. And that's your answer. Put on P there too.